A cart of mass m enters a smooth vertical loop of radius r with a horizontal speed u at the bottom of the track. And when this cart reaches the start of the circular track, the speed will still be u. So let's draw. When the car comes in at the entry point, the speed is still u. And then it goes around the circle and reaches the topmost point. So let's draw that diagram. So imagine the wheels are in contact with the track at the top. Now let's draw the free body diagram of this cart at the topmost point. So the mg weight acts downwards. And in this case, since the cart is trying to push away from the surface at the top, the normal reaction will be towards the center, downwards. And now we can write down the centripetal force, which is the net force acting towards the center, which in this case will be mg plus n. So let's write that down. Mg plus n will be your centripetal force, and we can equate that with mv square by r, where v is the tangential speed of the cart at the topmost point, which I have represented over here. Now in the question, they have given one special information that the cart just manages to stay in contact with the track. See, this is the keyword. Just manages to stay in contact implies that the value of normal reaction at the top is approximately zero. So we are going to assume that n is approximately equal to zero since the cart just manages to stay in contact with the track at the top. Now, if you put n as zero in this equation, we will get mg equals to mv square by r. M will get cancelled out. And if we make v as the subject, we'll get root gr. So this is the velocity of the cart when it reaches the topmost point. So this is the velocity at the top. In the question, we are supposed to find the speed at the bottom. For that, we will use the energy conservation rule. We will write that the energy of the cart at the bottommost point will be equal to the total energy at the topmost point. Now, energy, remember, is kinetic energy plus potential energy for both cases, bottom and top. At the bottom, the cart was moving with a speed of u. So kinetic energy we will write as half mu square. Potential energy will be mgh, but the height we assume as zero on the ground. So potential energy is zero. This will be equal to energy at the top. Again, we have to do kinetic plus potential. Kinetic energy at the top will be half mv square, where we had found earlier as root gr, plus potential energy is mg into height, h. Now, what is the height? If you observe the height of the topmost point to this particular point, let's draw an arrow. So from the topmost point all the way till the ground, this entire length, which is the height, is equal to the diameter of the circular track, which is equal to 2r. And hence, let's put the value of h over here as 2r. So let's simplify. We'll get half mv square, half mu square on the left hand side. On the right hand side, we'll get half mv square plus mg into height is 2r. Now the v, which is the velocity at the top, we had found out as root gr. So we square it. So we'll get half mgr plus mg into 2r. On the left hand side, we'll get mu square by 2. Now you can see m is present in all these expressions, so we can cancel that out throughout. And if you simplify, we'll get u square by 2 comes out as gr by 2 plus 2gr. On simplification, we'll get 5gr by 2 on the right hand side. Now let us make u square as the subject. U square will come out as 5gr, as the 2 in the denominators will get cancelled out like this. And finally, we make u as the subject. So we get root of 5gr as the answer. Now this is the minimum speed of the cart at the bottom, such that when the cart reaches the topmost point, it is just in contact with the track. And hence the answer for this question is option A.